Good morning, sir.
Morning. Is it morning? Is it still morning?
I haven't checked.
Phone on silent.
Mine's already on silent.
Ah, what a professional you are.
Yes, yes.
It is 19 minutes past 11.
There you go.
On Tuesday the 24th.
We are still in the AM.
Which is payday. Not for me.
For the boys.
For the boys. It is still in the AM. So, we've started off on the...
Back in the engine room of dreams.
We're in the engine room of dreams, and I thought we would do an interesting little spin. I've got to start measuring up bottom end stuff, so I've got to measure pistons, bore, and what I think I was going to try and do is show you the difference between an entry-level toolkit, so like what a home builder would do, and then what a professional would use.
Yep.
Because obviously it's so hard to build a V10 block. We'll do it in stages like we did with the RS3, so we'll do the assembly in stages. But like first out of the block, we've got to measure the pistons, and so we'll do it with a mic, and then I'll put it in my rig, and then we'll see how close we can get. The hard bit is obviously my mics are quite accurate, but it gives you an idea of what's what.
Yeah,
so
of course.
Let's get some pistons out of a box. Let's get scales out. Let's see how accurate the pistons are and bits and pieces to start with. Can't beat installation instructions.
There we go.
That's the key. So let's go through. This is the data sheet. So let's go through, walk you through this. Chuck that over there. We got a pen. Every manufacturer will give you a different rod sheet. These are CP Carrillos, so they give you obviously your job number and bits and pieces and your part number. So it's for a Lamborghini, it's for a 5 litre. They give you the bore in inch, which absolutely annoys the living out of me because no one works in inches anymore. 3.248. And this is my life.
Converting numbers.
Yeah, which is 82.499 mil.
You are basically Carol Vorderman.
Just not as hot. Do you remember? She was banging, wasn't she?
Mate, she's over 60 now, and some would say still quite hot.
0.124, so top ring radius is 3.14 mil. And I sit there and I do this for every measurement, so I haven't got a 3.40 and 0.122. 3.09. So they give you the forging number, they give you the dome height, I'll find the piston, so you can start to work this out. They give you the dish volume, important.
Yep.
Because it's not flatty, it is flat, but it's you see? Gappy. Yeah, so you can see it here and here.
Yep.
It's hard because it's reflective.
Yeah.
It tells you what the volume is if you flatten that out. So we can, when we CC the block, we can do that. It's not a problem.
Yeah.
So it tells you what that is. It tells you what the top land volume is. It tells you what your piston to cylinder clearance should be. Now, this is not something we can set because we've got stock block and we've got stock piston. So this is 0.0024. Yeah, 0.06 mil. So they want 2.5 thou. 0.06.
So you've got to work with that.
Yeah, we can't change that.
Yeah.
If it was bad, then we would have to do something. But is what it is.
Yeah.
Because if that was a linered block, I would do that to the number. I would measure each one of these. If they had any variation, which they shouldn't, but if they had any variation, I would assign them to a block, and I would get them. Like if Capricorn do our blocks, I would tell them exactly what I want in each bore. And the other thing we've got to do is, so we've got pin diameter, which we will measure.
It's become an unboxing video, this as well.
It's an unboxing and a measuring. I hate trying to get these out. Yeah, so we've got pin length, which is a 2-inch long pin. We've got pin diameter, which is 0.787, so it's 19.98mm pin. And then the hole it should go into is 0.7878, which is a 20.01mm. So they want 0.03 clearance.
Yeah.
So we can measure all that. Then we have got things like ring groove width, groove diameter on each one, the pocket depth for each valve, the pocket diameter. So that's important to know the pocket diameter, because you obviously need to know why they've given it to me 1 in inch and 1 in mil. I have no idea, but we obviously need to know what our valve diameter is, our valve angle. Yeah, so we know that on the intake we're at a 23-degree intake angle, and on the exhaust we're a 21-degree valve angle from center. And then we know what our valve diameter is, because if our pocket cut is wrong, our piston to valve we could clash.
Sure.
So piston to valve, you've got 2. Yeah, so you've got this clearance. Yeah, but you've also got, if I do it there, if your pocket's wrong, you've got that clearance.
Yeah.
Yeah, so you need to know what both of those are. And measure a moot, lad. This isn't a fancy spec, so to speak. It's not anything out of this world. It's what I would say is an OEM measurement build. So it's a brand new stock block. It's OEM pistons. OEM CP pistons are OEM size. OEM pins, OEM rods. Weights are just going to be different. But in theory, if I put a stock piston next to each other and we measured the physical dimensions, should be the same.
Fingers crossed.
Fingers crossed.
So this process you've got to go through for every build, whether it's
no, you don't have to, but we do.
Okay, that's the point.
No, okay, let's go back and say that again. Yes, you should.
Yeah,
but people don't.
Yeah.
So I watched some guys in the UK the other day doing videos on McLaren stuff, and they are not engine builders. Yeah. They are engine assemblers, because they're just smashing bits together and they are not measuring anything. One part of the video, it was measured. They were measuring with that.
Okay.
All right. So, like, if I was measuring a pin, that's zeroed. That's a good mic. That's 9. It goes to 2 decimal places. 19.99, 19.98. Like, you can rock it back and forth. It's not 20.06.
Yeah.
Do you know what I mean? All I ever use a vernier for is to give me maybe 1 decimal place. I never use it at 2.
Yeah.
So if you're about to get an engine built, go and ask your engine builder what tools he's using, and that'll tell you everything you need to know. But this isn't a preachy video. Let's just,
yeah.
You know what I mean? It's not. This is more about how you can measure it versus how. I'm not even the top level engine builder. How the top level measure it, because when you go to Formula 1 factories and stuff like that, there are 10 levels on from me.
Yeah.
But what the important measurements you need to look out for. We've obviously got a piston weight, we've got a compression height, so we go from the centre of the pin to the deck face.
Okay.
Yeah, so that's called our compression height. So we can vary that. So normally, if you go for a low compression piston, if I show you with my band, so from centre of the pin to top of the piston, that's essentially our compression height. So if you can imagine, if we were doing a low comp piston, yeah, we might do something like that.
Yeah.
So we would bring it down. Where you start getting problems then is if you start bringing your ring pack down. So you've got, I can't even bloody see them. Top ring,
Yeah.
quench groove, second ring, oil groove. If you start bringing those down, you don't want to remove any more support between the rings because you need the ring lands to have support. But if you start moving them any more down, you start bringing a ring pack into the pin relief or into the pin area. So you'll see some pistons where the oil control ring, you have to put the piston on the ring on the rod first, and then the oil control rings cover the pin, so they come down and shroud the pin. So you don't need low compression pistons on this stuff, so we don't really run into that problem. But that's something when you start speccing pistons you've got to think of. We've then got what's called a turn diameter, or basically our piston size and our gauge point. So from 0.4 of an inch up from the bottom of the piston, 3.2456 should be our widest point. So that's how we measure it. All right, because a piston does that. Yeah. So if that's a gauge point, what did they say, 0.4? So that, ignore the place of the pin, it's just a rough drawing, but X should be our widest point.
There we go.
Sounds fancy, doesn't it?
It does.
Right,
Yeah,
let's
good math.
have a swig of tea. Let's get everything laid out,
Yeah.
and then we can talk about the main things you should measure, what can catch you out, and then we'll do some comparisons between tools and bits and pieces then.
Let's do it.
The OCD section.
There we go. Numbering.
Numbering. I might run out of desk space. 6. What comes after 6? Before 6? 5. Shuffle everything over.
It's like a magic trick, this. You start moving them around.
No. I do like it when it looks factory when it's laid out right. So I label them first because the valve pockets are obviously different size.
Yeah.
So I just label them first, and then you've kind of got the orientation right. Then you just.
It's a nice straight line as well. Look at that.
Is it straight?
Fairly much
feels
so.
straight. Then we'll go pin. They're all the same. Check the part numbers. Don't just assume they are. Nice data sheet, which we will tuck out the way. Ring packs. Then I always order cram locks, but these haven't come with cram locks. So cram locks are so that's a normal ring circlet.
Yep.
And that's a cram lock.
There we go.
Do you see the tail?
Yep.
And the tailing is for that tool.
Which is a lifesaver.
Which is a lifesaver. So I always spec them with cram locks. They didn't come with cram locks.
Yep.
I got to remember what I took that out of now. That one.
Look out, you've broken the system.
Broken the system. Right, let's get these open. Oh, no, that was that. 78703 SLX. that's that one. Don't cut your fingers.
So again, with everything else involved with engine building, it's being methodical, it's double checking.
Yeah, so everyone goes on about blueprinting. The process of blueprinting is to build an engine to a blueprint.
Yeah.
It's not a magic set of numbers or magic set of clearances or values or anything. It's not a power. It's blueprinting is a process.
Yeah.
So it's the process of blueprinting something. So I think people get that misconception wrong. So it's.
Well, I don't think it helped in magazines. I mean, magazines back in the day, you'd have.
Blueprinted engine,
yeah.
mate. Means shit.
It was
means nothing.
Every engine spec in the car mags was lightened and balanced, ported and polished.
Blueprinted engine.
Blueprinted.
Yeah. So if you build an engine to Audi blueprint, it just means you've set the clearances and you've set the ring gaps and you've set everything to what they say. Now the difference between what I would do and what Audi would do is their window for it being acceptable is much bigger.
Yeah.
So for example, if you pull apart, if you go into the workshop manual, 3250, 3250, 3250. If you go into the manual in ALSA for building a V10, it will tell you that the ring gap, the top ring gap, should be between 0.25 and 0.35 new, and maximum wear limit is 0.7.
Yeah.
If I pull a ring out and it is 0.7, that is going in the bin, mate. That is a problem.
Yeah.
You know. So we'll do ring gaps for this, and they will be bang on the money. So steel top ring, or rather chromoly top ring, Napier cut, cast iron second, and then oil control ring on the bottom. All right, and then 2 guide rings.
Yep.
So that is what's called a barrel cut. I can get rid of all that because all that noble stuff I can't use.
Start afresh.
So that is a barrel cut top ring. Yeah, and it's even. It's a Napier cut second. Yeah?
Yeah.
And then it's a guide ring. It's the spring, so it will look like that.
Mm-hmm.
And then a guide ring on the bottom. I always put, just because it's easier to draw it, isn't it? So that's how the oil control ring looks, right?
Yeah.
And I'll always set it so that those 2 points are facing down.
Let's have a look at that. Hang on. There we go. Yeah.
You see it?
Yeah.
So they're always facing down. The other 2 rings have got an N on the top, so you just have to make sure that's your top. And then for orientation, which on a V10 you have to be careful about, so looking from the top of the piston, so if you go, this is major thrust, right, which is where the piston when the piston's pushing the crank in that direction, this is major thrust. So it's pushing against the cylinder wall, right? It's major thrust. I don't put anything that side.
Okay.
All right. So my ring layout will be top, second, right? oil control ring join is there, yeah?
Yeah.
And then I'll put a guide ring there and the other guide ring there. That's how I would lay rings out. And that is how I have always laid rings out, and I don't change it for anybody. And there is loads of theories. Oh, there's theories where you go, right, okay, so on a piston, and that's the top, you go, well, you do it in thirds. So you go top, second, oil control. The reason I do it like that is I essentially bring those two round, is I don't want anything in major thrust.
Yep.
Yeah? Because if there's a burr on a ring, or the ring is doing anything, it'll just leave a groove all the way down the bore. So that's why I do it that way. Nothing goes on major thrust.
Yep.
I don't know. Someone will tell me I'm crazy. Someone will tell me it doesn't matter.
I'm sure somebody will say something in the comments.
And this is the sort of thing, right? Whereas if you start getting engine builders together now, it's those discussions where people really geek out.
Yeah.
So like if you're a member of ERA or Ben, someone his name is, he does a EFI Academy, stuff like that. They do like engine building classes.
Yeah.
That's the stuff that you know you can go crazy about. It's like on some race engines, I thin down my mains. Sorry, my big ends.
Yeah.
To take away the rotational. But by doing that, I increase the load on the bearing because I've got less surface area, but I reduce friction, and it's
everything has a knock-on effect.
Yeah. They are good. These are good oil catchers for lubing rings. That's another discussion. People say, oh yeah, you don't oil the ring pack when you put it in. Whereas I saturate mine. I flood the rings.
Okay.
Before I put the bore in. And I always have. Whereas other people go, oh no, it causes this, it causes that. Right, let's get that one out of the way. So we've got pistons out, we've got rings out. Some of them. There's some scales. We have a pen. I have got engine logbook up, but I think what I'll do first is I'll put it all down on paper.
Old school.
Old school.
I do like seeing it all laid out. It's quite satisfying.
I don't know whether this pen's going to be any good, so we'll have to see how dark it is. Right, so we're just going to do 1, 2, 3, 4, 5, 6. Wait. Zeroed. 265.4. I tell you what, I won't do all 10 because it's just going to get monotonous.
Repetitive.
Yeah. So we'll do like 3.
Yeah.
266.2. That's what we got there. 0.8 of a gram. 267.1. We do 5. 265.5. 266.9. Now, if I'd done this in engine logbook, it would straight away go give me a red marker for high, 265.4, 265.5. So it'd highlight my low and my high.
Yeah, okay.
I can't draw a circle backwards.
Have you just discovered that?
Yeah.
Wow. But can you throw with your left hand?
Yeah.
Are you right-handed?
Yeah.
Yeah, you see, if I throw with my left hand, I throw like a girl. Actually, you can't say that anymore, can you?
Missus will knock you out for saying that.
She is left-handed.
That's weird. I can't write a circle backwards.
Let's prove it. You're doing an ellipse. Oh.
That's weird. There you go.
Let me have a go.
Go on. Are you left-handed?
No.
All right. So not only are you doing left-handed.
It's like a 4-year-old's done that.
Yeah, Sienna's writing on the wall again. Although she's 7 now. Pins. 80.3. 80.3.
Ooh. Consistent.
80.4. Notice how the heaviest pin is also on pin. I've done it on pin 3 as well. 80.4. 80.3. So they are more consistent. Right, these should all be 1.2, 1.2, 1.2. Whoa, 1.2. 1.1.
Ooh.
So that's clips, pins, piston rings. 19.6. Boy, steady on that. 19.6. 19.8. 19.7. 19.6. And 19.6. Now, before we even started linishing the underside of the pistons, so if we go across this again and we do the same, 80.3, 8.4, so we've got 2 highs and then the rest are the same. Yeah, that's the lightest. 9.6, and then we've got and then that's the heaviest. Right. So if we work on now, so straight away, I would swap those two because that balances out that piston by 0.2 grams.
Yep.
I would swap the pin. So that gets me down to 267.0. Do you see what I'm doing? I'm trying to get, you're trying to find the total combined number. So if we just do, so if you do a sum page here, which is what's so good about that, is it'll add it all up together for you.
Does it for you?
On the fly and kind of work it all out. But if you go 265.4 plus 80.3 plus 1.2 plus 19.6, 366.5. We'll just do the next one for an example. 266.2 plus 367.5. So I'm a gram difference already between cylinders 1 and 2.
Significant.
It is. Now, I saw something somewhere, I think it was Power Nation, and they were like 10 grams at 8,000 RPM was the equivalent of like 180 kilos.
Wow. That's insane.
That's mental. So what I would first of all juggle the parts around, yeah, until I could balance it out as much as I could. So I would put, like here where we've got a big disparity between heaviest and lightest, I would put the heaviest pin with the heaviest clips and the heaviest ring pack onto the lightest piston, because at the end of the day that all lives within that assembly. Yeah. Then I would calculate out my numbers all again, and then I'd straight away I would go, right, okay, so cylinder 2 I've got to take a gram off that piston to match it to piston 1, and we do that by essentially, there's lots of different ways you can do it depending on how much you want to take off. On these I wouldn't really do much on the underside of the crown. If it was, half a gram, I would probably linish ever so slightly a little bit there.
Yep.
Yeah. We don't really have much room on the underside of the crown. So if I draw, so in that tie, in that dicky bow area.
Hang on, let's get onto that. Yep.
I wouldn't really do much, but what you could do is you could, let me get a different pen, mate. If we do it in green, purple. What you could do is in there.
Okay, yeah.
Yeah, so
yep.
There will be an argument, and it's very much feel about how much you've got to take off, about taking it, because that's the strength of the pin. And there will be people saying, oh, you shouldn't do that. And I do agree, but to a point, if it's literally a little nick to get a couple of tenths, you should be all right. But that's how you would machine or linish. And when I mean linish, just gently buzz it with a linisher or a grinder, just to get the weight down. If I show you what we would do on a rod, yeah. So the other measurement we have to take into place, so where we move from the reciprocating assembly, reciprocating being up and down, to the rotating assembly being the bit that goes round and round, is big end and small end weight, right?
Oh yes.
So it's swinging, try and calm it down a little bit.
That's it.
Right. Yeah. So the scale is saying, it doesn't, I try to set it up as perfectly as I can so the rod is level, but at the end of the day, if you're eyeball close, it doesn't matter, because as long as you don't touch anything and you do all 10 rods the same, you'll be fine.
Yep.
So right now, that rod is 378.3 grams on the big end. Yeah?
Yep.
We'll be able to do maths and work out what the small end is once we've worked out the total. 378.3. So now all we'll do is we'll unhook it off the holder, take a tool off, 0R, and we are 527.5. So our small end weight, you'll get this on a spec sheet as well. And what I normally do on a spec sheet, 527.5 minus 378.3, it's 149.2. They'd give you the big, CP give you the big end and the small end weights.
Right, okay.
On the data sheet. And what I would try and do is I would try and take the first one and set my, so if I show you what I mean, right? So if I rehang this rod, right, and then if you come here, look, Dav, and look at the scales.
Yeah, right. Oops, there we go.
You see the numbers climbing.
Yep.
And all I'm doing is I'm shifting the angle. So then if I tip more weight into small end, you go the other way, look.
Mm-hmm. Got it.
So that's why you try to keep it the same.
Yep.
The reason we then work out, we've got to take the small end weight into account in this measurement.
Yeah.
Because it's reciprocating end, and then the big end weight we can manage ourselves. So say for example we had 378.3 and then we had 379.2. What we would do there is normally ever so slightly down the sides, or you can just gently take a little bit off the ribbon there.
Sure.
If you've got to do anything similar on the small end, again ever so slightly over the top to take weight out of the small end. And when I say linishing, it's literally a little bit of sandpaper. It's not like you've got a grinder and you're grinding gouges out of it.
It's gradually, gently.
Yeah.
You know.
Yeah. Christ, mate. 0.1 of a gram. I mean.
Yeah.
That circlet is 0.6. Do you know what I mean? So it's not. It's not a lot there. to give you, those scales are pretty damn good. They're to 1 decimal place. I have got painter scales down the bottom as well, that go to 2 decimal places, that places like the body shop next door would use, but that's more than adequate for what you need. That's got me through many an engine build, this, because painter scales 500-600 quid.
Yeah.
For good ones, and then obviously you get them calibrated. So for a start of building engines and weighing everything out, that is more than enough. And if you're worried, you can get can't think of what the correct name would be, but standards, like old weight standards,
sure, yeah,
to check your calibration of your scales, which again we've got to make sure anything we use is right. 10 quid off Amazon.
Yeah, I know somebody who's got some of those scales, but they don't measure engine parts on them. Right.
Okay. See, now I would want a really accurate scale to do that. I might be giving away, product. 10th here, 10th there, mate. A tink there, mate. You know what I'm saying? A nice set of scales, or a very, very accurate set of scales, is a nicety, and I would say that the better, it's that never-ending spiral of upgrading your tools. Yeah. That'll be fine.
Yeah.
That'll do a good job. I would much rather see someone have a 15 quid set of scales off Amazon, and they're just jeweler's scales, but a really good micrometer for measuring pistons, than a baller set of scales with Bluetooth and blah 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 blah, blah, you know, painted scales and a shit mic.
Yeah.
Because the mic means more than that does. Absolutely. At that point.
Yeah.
We go to 0.1 of a gram building engines, but there's lots of people out there that don't even weigh engines, and the factory don't weigh engines.
Okay.
What you've got there out of those, to some people, they won't even weigh them, and they'll smash them in an engine.
Yeah.
And it will be fine. But that's then trying to explain to people, those are the gains, right? That's what you're trying to gain on everybody else.
Yeah.
Can't remember where I got that from. Maybe Summit Racing. What, $100?
Okay.
You can make it yourself.
Yeah.
It's a sheet of metal. It's a pole. It's a stand. And it's a hanger. And that is it.
Job done.
Yeah, you haven't got to go crazy. That was the billiest basic one on the website, and I've never changed it, so that's fine. Right. So these really, well, there's 4 methods, and we've sort of progressed up through them. You've got a micrometer, which will measure a piston for you.
Yeah.
So 82.42. If I take that one out of the holder, you've obviously got our Mitutoyo one, which has got a fancy upgrade on it. Let me just put that out of the way a sec. We've got an old manual one, and the struggle with this is working out your gauge point. So let's say we have theoretically worked out 0.4 of an inch, and it's measured up from the base of the piston, and then you've kind of got to right, so what do we have? We had 82.2.
Yeah.
I've got 82.45. Right?
Yeah. Slight difference.
Slight difference. Right. Then we go to this all go. Bloody hell. let me calibration stick out. There we go. And this is a similar sort of deal, right?
Yeah.
I've got 82.449.
Okay.
So we had 82.2. We had 82.45. We had 82.449. Right? So you can see how the accuracy's going up.
Yeah.
I was within 0.25 of a mil. And then this one is 0.01 off. Yeah?
Sure.
And then this bad boy. The other function as well, which I didn't show, is this does data capture as well. So that goes straight into my engine logbook up in that top left corner, look.
Yeah.
So that carries straight in. As does my measuring centre. But the advantage of my measuring centre is now I can make sure I set my my height as well, if that makes sense.
Yeah.
So what we will do here is we'll put my standard in. We've got 76.2. 0.1 should go out enough. So I normally right, so that is 76. So I've got to preset that to 76.2. There you go, preset. Okay.
Yep.
So 0 on that gauge is 76.2. So we know we're 82.5. So we can come all the way back out to that. So we take our standard off. Right, now what I've got to do is make sure 0.375. I can't remember which way around will let you do this now. Is point. Right, so 0.5. So we set that to 0. And we will set our height, so I'm just, it shouldn't be any different. So that's 1/2 inch, right?
Yep.
So I've got 2 gauges there. All right, so what I've essentially measured, we've got to take into account that the center of that, yeah, is the distance between those two.
Okay.
So that's, I can't remember what it is now. See what happens when you do it in bloody inches. But basically, when that's all measured out, 0.5 of an inch, I've got to go, because that's a millimeter gauge, 0.1. So if I come down now, if I come up, yeah, to the center of that, post, right, is 1/2 inch.
Okay.
So if I come up, that's 0.4. That's my gauge point. Does that make sense?
Yeah.
So now my gauge point is set on each piston, right?
Should be easy now.
It should be easy. So we know we're 82.5, so we wind into 82.5, right? No, we're 82. What are we? Yeah, 82.5. Right. Cool. Ed's not in it this morning, mate, I tell you. 82.437. So even a 3 decimal place micrometer amount. Right, the advantage. So as long as I don't... That's one piston, right?
Yep.
This is the advantage.
Because you've got a few of these babies to do.
.42.432. 82.432. So the advantage is a repeatability. My gauge point is exactly the same on all 10.
Yep.
Haven't got to touch it. So that's the difference between measuring it with a micrometer, a very old, don't even know, MAHA manual gauge,
Uh-huh.
a baller Mitutoyo
Yep.
mic, and then the bespoke measuring centre. Now, to a majority of people, they'll go, yeah, but you're nearly there. But when you start then talking about piston to wall clearance was 0.006 mil. It's pretty scary, that, isn't it?
It's going to have an impact.
Yeah, well, straight away, like, you're 0.05 of a mil out. I haven't got that right. Piston cylinder clearance, yeah. 2400. Where's me measure jiggly? 0.0024. Yeah, 0.0. Oh, too many zeros, Rick. 0.06. So when you sit there and you go, oh yeah, I've measured it at 82.5, and you're actually 82.45, or you've measured it at 82.437, and you're actually, do you see what I mean? The numbers are bigger.
Yeah.
So that's the difference between the different tools as you go up.
So you increase the accuracy, you can get everything to a more refined, what, tolerance would you say? Or
Right. Now, I'm always going to turn around and say that's the best thing to buy because it's the most accurate.
Yeah.
Actually, out of everything we've got here, everything between the three, if I was saying to you, what tool do you get? You go and get one of those.
Yeah.
You're going to get one of those with a not the cable. You go and get a good 3-piece 3 decimal place mic. Obviously it comes with a standard, as they all do, and then you can sit there and get the best accuracy. I would have said if we spent a little bit more time around our gauge point, because you've got to make sure you're correct that way inclined, and you're correct that way inclined.
Sure.
Because they're not perfect circles, you'll get better numbers. So, not a chance. Not a chance. That's probably the best bang for buck. It's probably the best bang for buck. I wonder if we could get. So now I know that's an 82.437. What's 0.4 of an inch in mil? 0.4 is 10 mil. See, this is just the fiddliness.
Yeah.
You shoot. 82.43. .375.1. Well, let's go to trying to figure out which one I trust. You see what I mean? Like my mic.
I guess the mic is what you've used for years anyway before you got this.
82.436. Yeah. Doesn't matter what I do. I'd always trust this.
Yep.
But it shows you, like, even. Yeah. 82.436. And I got 82.437 on that. So I was a bit, once I sorted my gauge point out, I was better. So that is good. It's just fiddly. Yep. 82.438. 82.437, 437, 439. So you can get that as good as that. Your problem is your gauge point.
Yeah.
That's why I rolled it up and down in a gauge point to see how much the barreling was affecting it. So micrometer, no good. Cheap crap one, no good. Well, it's 2 decimal places. So your best bang for buck is this bad boy. Coolant proof number 293 23330, and I shall tell you how much that is.
You get the full service here.
You do. Then add Toyo 293 233 260 quid plus the VAT.
There we go. We need a link now. Buy here.
Right, okay. Yeah, MAHA Toyo if you want to sponsor this video. So a good mic stand, a good mic, some patience and some accuracy on doing your gauge points, and you can get within 0.001 of a mil of what that'll do.
Yeah.
But now I've got that set, I can do 10 pistons in seconds.
Yeah.
Say 10 seconds a piston. And then with the data, that cable goes in the side of this mic. I just press my button and it copies it straight into my
engine
logbook. But that shows you 3 different tools or 4 different tools. But notice how it's all in how you set it up.
Of course, yeah.
Yeah, so if I cock up, that's what gets me with them bloody standards. I need to buy, like, what inches to mil, you can make mistakes, which is why I try to write everything down. But you get your gauge point wrong, and your measurements are wrong. So it's all in how, it's all in how you set your tool up. Yeah. Right, let me undo this, and then we can get bore tool out. Ball measury jiggery. For measuring ring gaps, I have 2 very, very cheap tools. That is I don't even know where I got them from. Rubbish set of feeler gauges, as in they're rubbish because that's a snap-on set. I've had these donkey's years, but they're imperial and they're folded over. So they're imperial with a millimeter conversion on them. I don't like them because they're not straight. They do jobs, they're good for doing shims, but they're not good for doing ring gaps. I like these because of the increments they come in and because I can take them apart.
Yep.
So I've got 0.02 to 0.1, then I've got 0.15, 0.2, 0.25, 0.3, 0.4, 0.5, 0.75 and 1. Never use them two really. But between them I can figure out exactly what I need. The other tool I've got is this.
Yep.
RPM engine, at RPM engine. I bought it off him, rapid prototyped, but it's repeatable. And that just sets my ring gap. That is it. That's what I do it to. Every time, every one, you just set the bore diameter.
And away you go.
And that is it. All right. Pop your ring in. Like so. Keep it near the top. Put one stool on the gap. Push them down together. I always run my finger around to make sure it's even. And then just pick a start point. So 0.07, 0.08. I think it's going to be a 0.9, but I feel that 0.1 would be too big. Yeah, 0.1 is too big. It's just a 0.9. By the time I've squared that off, because rings are never perfect. But if you do, that's the bore. Yeah. And when a ring will come in like that, and it will basically sit. Not all, but the tendency is they sit like that, right? So you've got to make sure, if you measured here and you went, well, let's say that's 0.06, and you put a gauge in here and that's 0.15,
yeah,
you've just got to be careful where your start point is. So normally I would square the ring off and I would put it in a tool. If you take the end of the ring and it's coated, and I would put it in my ring grinder and I would touch off and it would clean up that section.
Yeah.
And then I put it in a little bit more and clean up that section, clean up that section, clean up that section, blah, 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 and on and on and on and on. So these at the minute now, what did I say it was? 0.9, 0.09. So in the inside, let's do it that way. 0.09. Let's see what I can get in right at the tip. Nope. So I can get a 0.15 in there.
Yeah.
So my ring gap tapers from a 0.15 to a 0.09.
Yeah.
So what I essentially need to do is, on the very outside edge, take off 0.06 to make it square across the edge. And you do that, and you'll literally just be doing that, and that, and that, and that, and that, and that, and that. Now on some engines, you'll get the rings, and you'll put them in, and they'll be almost bang on the money. So for example, let's give you a number. So if I was going to run a top ring at say 0.4 mil, I'd run a second ring at 0.45.
Yeah.
I'd normally go 0.05 over. So that now, they're too tight regardless to what we want to set them to. So I can now put it in my tool. I'll square off the ring on the one side when you ever do one side, remeasure it, and then I'll go, right, in theory, once I've squared the ring off, I should be 0.15. Yeah? And then I'll do it for all of them. Tools to measure ring gaps, that's all you need. Don't need anything else. Modifying ring gaps or changing your ring gaps is then a different story. So I used to sit here with, I don't even think I've got them anymore, with a diamond file that looked like a, not these, but like these.
Yeah, yeah.
I would sit there with a diamond file and I would go, right, and then I would hold it up, butt the ring together, make sure it was square, look down the end, make sure I wasn't going off at an angle, because if I was going off at an angle, I'd get that. Ooh. Yeah?
Yeah.
I'd clean the top and I'd not clean the bottom. So it takes patience, takes time, especially when you do top ring because they're hard as nails or hard as chrome. We do a needle file, diamond file. I'm going to just sit there with a ring file and just file and file and file and file and file. And honest to God, that could take a day.
A day?
Yeah, yeah.
Wow.
Yeah, I mean, just take forever. Just take forever. You get a feel for it. By the time you get to the last one, you kind of get in there. So to do ring gaps, a set of good diamond files, a little niche tool to give you repeatability, which is better than putting your piston at risk, and a set of feeler gauges. What's that, 50 quid? Do job, it's just time. What will change your ring gappage is one of these bad boys.
Aha.
So that's
grinder.
Grinding wheel, polishing wheel to taking the burrs off, and then a tool for, yeah, holding your ring. Whee! Hold your ring, mate. So you want to get your diameter right, pinch your ring like that, put your lock back, and then you essentially turn your grinder on or touch off, put your grinder on, yeah, and then essentially at 0 I should just be glancing.
Yep.
Yeah, and then I'd be gently moving it back and forth, moving back and forth. Bearing in mind, look, when I move it back and forth, how much my needle moves.
Mm-hmm.
And then essentially if I go, right, okay, so I'm at 0.2 ring gap and I need to be at 0.3, that's me at 0.3. Now I don't do it in one hit, I'd be doing this. Back and forth, back and forth, wind it on, gently, gently, gently. And you're listening to the load on the motor. And then you get to about there, and then you come off, put your lock on. Clean your burr on the inside, outside, top and bottom. And that is it.
Job done.
In theory. So again, that's probably a £1,000 tool. But that's quicker.
Yeah.
So if you're building your own engine for your first time, that's all you need, 2 ring gaps.
Yeah.
Yeah. If you want to measure your pistons because you're going to get your block machine and you've never done it before and you need to give an engineering shop measurement, I would probably say don't. Find a good engineering shop. Take your pistons and let them do the measuring for you. If you're going to build more and more engines, then at least start with a good 3 decimal place digital MIDI Toyo.
Yeah.
Put my feeler gauges back now.
And if you're building V10 engines like they're going out of fashion,
yeah,
you need all the tools.
Yeah. And that's it. This is like 8 years of. I had the micrometers were one of the first things I bought.
Yeah.
And now all of a sudden I've got the measuring centre because it was like, right, well, we move on to the. I'd sort of caught everything up. So you just get like these. There's better feeler gauges out there, but these do a bloody good job. And I like how they work. I like that I can break them down and lay them across the bench like that. So I've always used, same as that ring setting tool. People use valves, pistons or whatever. Never done it. same as when you first start building engines, you use these. That's for putting rings in, or pistons in bores. The most hateful, awful, fucking stupid things I've ever used in my life. I've broken more rings using that than I have using, I don't think I've ever broken a ring using these. So these are tapered cups. So what you do there is you take the right one, 82.5, so that's 5 litre Lambo, R8 and Hurricane, McLaren. They're the 3 bigs we do. And you would literally, everything's assembled, rod on a piston, rings on it, and you would just put it down to about there. Everything's oiled up. In you go. Yeah. Sat square. Hold your rod on the backside, and I don't even hit them anymore. I literally just go and push them in, like that. All right, it is wrong. I appreciate that, but that gives you an idea of what is what. Oh. Yeah, some people use pistons as setting tools. I don't like it because I don't like putting my piston at risk. Yeah. I try to move everything around as little as I can. Yeah. So again, you can start off building engines with those, 10 quid off eBay or whatever, and then your engine building, well, there you go. That is R6, 5 litre Gallardo, and I'm sure they do V8s, 5.2 V10s, and a McLaren. So there's brilliant. I need to order one to do the Murcielago engine.
Oh yeah,
because you just sort of collect them up.
Yeah.
Little tools that the home buyer, the home builder would never use. So this is a surface finish tester, right? So when you go and get your block machined or you have anything done, oh, stop. This now means I can test the finish of the block. I can test the finish of the boring. I can make sure it's repeatable. So it's a little diamond tip. I'll check that goes in there. I'm sure it will fit. And then you
come on this way.
What you lead. Yeah.
Mm-hmm.
Oh, that's too big. Yeah. So you sit your tool in. Like so, snug it down, hit start. That little diamond tool is now measuring the surface finish of the bore, the brand new bore.
That's cool.
And then it will give me the values of the height of the peak, the height of the value, and the R8, the surface finish. So there's arguments that you want to really, not a rough surface finish, but if it's too smooth, you don't retain the oil and you don't get a good ring seal.
Right, okay, yeah. Makes sense.
The main reason for this is if I'm asking someone else to do work for me, I need to be able to check what I'm getting back.
Yeah.
So like we have Capricorn do our liner blocks, or we have, you know, K&B engineering bore our blocks. So if I'm building these engines for people and I measure it and it's all over the place, I can go back and I could go, okay, we need to address this, or we need to hot hone it, or we need to get it redone, whatever it is. But at least I can.
You're in complete control. You know where everything is. Yeah.
Now that is not required for a home engine builder.
Yeah.
But where I'm building engine after engine after engine after engine, and we might change ring pack, or we might change piston, or we might put a different block in it, I know every number that goes into that engine.
Is that essential for the competition stuff you build as well, the GT3 engines and things?
I just try to. Again, you'd almost argue this is a sort of part of the blueprinting process.
Yeah.
So now I know exactly what my surface finisher is in my bore. I know what my ring pack is. You know, so if for whatever reason I start getting ring sealing issues, we know what went into the recipe, so we know what we can change later.
Yeah.
And the last tool, I suppose,
for today's show and tell.
Is bore mics. So I had an old one for a bloody long time. That is my original one. Alright.
Yeah.
And then I did upgrade part of it to use this. So, if I get that. Don't drop the tool.
Looking nicely presented wooden boxes, don't they?
So you end up getting your sort of measurement pieces. So they're no different. Like you put that one in or you put that one in. They both give you an 80mm gauge.
Yeah.
Right. Then you get your little shim washers, which should be sat here. So again, you can shim the measurement out. You've essentially got a mandrel, which has got a little needle on it that pushes on your gauge.
Mm-hmm.
I had that old gauge on it, and then I upgraded to a digital Mitutoyo.
Yeah.
So if I now move the needle down the bottom, I'm not in deep enough. That's what she said. There you go. Yeah, so if I now push on the needle, yeah. And trusty old thing did me well. It's a good gauge, it was a gift. And it did a bloody good job. The two problems I had. One, if I was trying to measure main bearings, I had no way of, it would only go so far.
Yeah.
Yeah.
That's
so
a limitation.
The problem I had then was if I mounted the engine on my cylinder stand, I'd have to measure the front bearings before I mounted it, and then I could do the back measurements from when it was on the stand. If I then needed to measure them again, I'd have to take it back off the stand. So the length was the limitation.
Yeah.
You just skagged your hoodie on my bench.
I'm all good.
So I looked into this, and I bought an extension rod. So now I can extend my gauge.
Yeah.
So I can do the whole thing. That was the advantage. I didn't go. Mitutoyo do some really nice self-centering ones, which is what you get if you look at like the Sun-in honing machines or anything like that. You get a self-centering one, and you pull a trigger on the top, and 3 little feet come out, and they center it in the bore, so you don't have to do that sort of swing in the bore to get it right. And it was 3 times the price of what this was.
Right.
So even I make decisions on what the price is.
Yeah.
Do you know what I mean? I can do a good job with this, and I'm not doing it enough to warrant spending. Bearing in mind they come in different sizes, so it was 0 to 25, 25 to 50, 50 to 70, 70 to 100, something like that. Anyway, they broke down similar to how the micrometers do. So to do a McLaren bore and a Lamborghini bore, I think I needed 2 gauges, and then on the big ends, again, to do a McLaren bore and a Lamborghini big end, I needed 2 gauges. So I needed 4 gauges.
Yeah.
Mate, that was at 10 grand.
Whoa.
And I'm like, yeah, I'm not there yet.
Yeah.
So that's a good starting place. If you do go and get one like this, yes, there might be a little bit, it might not be amazing, but the gauge, you can make the difference with the gauge. So I don't even know what that would have cost. I mean, it is a lovely piece. It's Matra, so it is nice stuff. But I think that was about 1,500 quid.
Right, okay.
Again, something that Brad at QMP did, who built that, is they made me
this bad boy.
This piece. So the advantage of this bore gauge as well is I could set it on my measuring centre. So Brad made a fixture that I could now dial a standard, measure it on a standard, put it into the measuring centre, and it's sat there stable. So I can now set everything as I need it to be. Because I don't know whether you've ever tried to set up a bore mic before. You would have to go. We'll do it with this one. So you would go, lock it off. Yeah, so it doesn't move, and then you'd be sat there with your bore gauge, rolling it around in your fixture.
Yeah.
Trying to set the value, so you could then go into your bore and roll it down your bore.
Sure.
Yeah. So the advantage of this is it takes out all this human slop.
Yeah.
Which is all that, and it now just, that's it. I set it on the gauge. I preset to whatever value I want. So if it's 82.5, I would set everything to 82.5, preset that to 82.5, put it in the bore, and it would go 82.499. And then hit the data send button, because it takes a cable in the top, and it goes on your
job done.
Goes on a,
so it's consistent. You can repeat
consistent.
it. Yeah.
Yeah. It takes out the human mistake you could make because you're trying to set a mic and then hold a bore gauge,
yeah,
like this, yeah, to store the value and make sure the gauge is right, and all around, or every time you move, bearing in mind you're trying to do it 3 decimal places,
yeah,
every time you move the number changes, the
yeah.
number changes,
yeah.
the number
yeah.
changes. And I did that for years. I did it for years. I built good engines with it. So again, it's a good solution, but you can have a rough bore gauge, and if that's the case, buy a good DTI and buy a good mic.
Yeah.
There we go.
Top tips.
Top tip. Buy a good mic and buy a good DTI gauge. Everything else you can make do with.
Yeah, you can get by with. Yeah.
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 You don't,
adequate.
You don't need a snap-on digital torque wrench.
Yeah.
Yeah. You can use an old manual one, as long as you know the numbers are good. You can use an old dial gauge. I used to, when I was doing angles, I still now, even though that's got an angle measure on it, I paint dot the bolt.
Yeah, yeah.
And I do it off paint dots. Because it's, what happens if I'm half sweep and a battery goes flat? And you learn that from a good craftsman. You can do a good job with bad tools. A good craftsman can do a good job with bad tools.
Yeah. But not vice versa.
No, I didn't start like this. A good torque wrench, a good mic, and a good DTI gauge, and I think you could build some banging engines, really. And then you just work your way up through little things. So we've obviously got all my little fittings and fixtures for my gauges. I've got 0 to 100mm in mics. These are my 2 original mics. They're my 2 original ones. they did a good job. Honestly, I think they're like, mate, I think they're like Chinese or something. Feeler gauges, you know, they measure right. I check them against the standard, and they're good. I have got a good vernier off Mitutoyo, and I've got an ARP bolt gauge for measuring rod bolt stretch. Cables for all my gauges that go into my computer, spare batteries for everything, security tags when we build an engine that I don't want opened, and then these are the offset gauges, the offset spanners, so I can have a spanner, I can be torquing a rod bolt and have a rod gauge on it at the same time. Let me find a rod, I did have one. So I would have the rod in the engine, if I do it that side because it makes life easier, and then I could have a rod gauge. Obviously it'd be on free length, so it would be on 0 because you do it from 0, and then a torque wrench set to beep at my max permissible stretch, my max permissible torque, and then I would literally pull on that with my torque wrench and my gauge would increase. So if I wanted 6 thou of stretch, which is what would be on your data sheet, you'd see it creep, 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 you know, and you might get to like 6, and then like 65 would be max permissible stretch, and your gauge would go off. So you just got to be careful with that. If you're going to do rod bolt stretch, you need these.
Yeah,
that's the way to do it. The manufacturers do give torque settings for rod bolts, but if they give a stretch value, we always use a stretch value. So I've got metric and American. You don't need all those. You could get away with a 10, an 11 and a 12, and you could get away with a 3/8 and a 7/16 to start. Well, there you go. I've got 2 7/16.
Yeah.
So I've obviously bought one and then bought the set after. T-bar spinners, they're nice to, like, they're easy to have. They're just blueprint snap-on ones. I get asked about these loads. So that's an F11 turbo and that's a T9 turbo. I use silicone hose for when I've sat heads on the bench, so there's no chance of grit getting caught underneath. I've got a Summit ring gauge, but typically being American, it doesn't fit anything British because the bore sizes in America are so bloody big. Different size soft springs. I have got piston hammer, so that's for knocking pistons in. A couple of very clean dead blows if I've got to do some tappity tap in. Some headstands. A long blower for going down oil galleries. What's that one? C63 Merc. A TDC gauge or timing gauge. Circlip pliers. Why I have still got that, I have no idea. Sentimental value, I think. Leak down tester, bore tester, compression tester, bore scope, a good quality straight edge. That is a very, very good quality straight edge. That's a Volkswagen tool. And yeah, so that's good for measuring heads, straightness, bits and pieces, couple of special tools. So old style valve spring compressor, a couple of timing gauges, pulley holder, and a big rivet gun for like the Daza rivets that we take out, like all gallery rivets. Cambridge locks, crank locks, variator holder, cram locks tools, variator tools, front pulley tool for a Daza, cam bridge holders, so as you lift the cam bridge on a V10 you use these, loads of timing tensioner locking pins, so gauges, oh they don't go in that, move on. So mag base, extenders and holders, a couple of different gauges, old school lapping tool for whatever reason in case I ever need it. Seal drivers and pullers. So put crank seals in, rear main seals in, DCT seals in, for taking valve stem seals out, slide hammer. And I have also got, because I did see it, valve stem pliers, Blue Point ones. They do a good job. Yeah, slide hammer. A couple of tools for oil pump drive gear off a McLaren. Another valve spinner. Oil pump tool for a McLaren. This pushes valve stem seals on. That's a special tool for a Volkswagen, but 9 times out of 10 I use a socket. And then McLaren Cambridge tool. That is a crank turner for a V10 I had made. And actually, that is good. That's where I started with a ring grinder. If you don't want to buy a file, or if you don't want to use a file, you can just use that. And then it's literally a filing wheel. You just turn the wheel. I hated the thing because when you watch the wheel, it's on the wonk. Yeah. And it does this. It's rubbish. Yeah.
Some serious tools there, bud.
It has built up and built up, but it's the same thing. I started with crap, or what I look at now and I'm like, how does I build engines there? But it takes you longer and you have to think more and you have to be much more precise.
Yeah.
And then as you build more and more and more, you can spend your money on tools. A lot of this stuff here isn't required at all.
Yeah.
Nah, not required, but people will go, well, what the hell have you got that for? And I'm like, because now I know.
Yeah.
Now I know. Every engine build I do, I know. And that's all that matters. Yeah. So hopefully, I didn't really even put much of it in, but we get asked a lot of questions about engine building and how to do it. And I noticed that we'd said we've gone through what tools we have, but we'd never really spoke about what tools you can do it with.
Yeah.
So hopefully it helps. Hopefully that's good.
I think so.
What tools you need to build a Lamborghini V10 engine?
Yeah.
Or Lamborghini V10 bottom end. So hope it's helpful. If there are more questions, or if I've missed something, then drop it in the comments and we will answer it when we do update next week.
Happy days.
Sweet.
Right.
And if anyone can remember the password to sign in for Windows 365, let me know, because I can't remember it.
Right, on that note then.
On that bombshell.
It's lunchtime.
It is lunchtime.
Yeah.
Let's go get some food.
Let's do it.
See you later.